So today what we're going to be learning is exponential functions, and within that we're going to be learning linear exponential. What's the difference between our rate of change and our average rate of change? And so we know from our bell ringer right here, hopefully you guys already did that, we know that the rate of change is our slope, right? So our rate of change, what's added over and over again. Remember our m, our y minus y1 over x1. Also, what's our constant, what's being added or subtracted over and over again. And we also know it's our rise over run. And so rate of change to remember. So if we're looking at the rate of change of this linear equation, the one, we can see I can points or an interval and get the same slope. So right here I'm going up 3 over 1. I could also do it again, up 3 over 1. So it really doesn't matter which points I choose. I will always get the same rate of change. Now, for exponential, it's different because you can see, I'm going to read the blue real quick, difference. That the red one with the exponential function, depending on which interval I choose, if I choose interval right here, that slope, so 2 over 3, is a lot different than this slope, which is 6 over 1. So it depends, all our rate of change will be different depending on the interval that's being asked. And I'll show you what that will look like in a few minutes. But when they ask for the average rate of change, for exponential, it has to be the average rate of change because it's not the same rate of change all through the function. So right here, I'm going to be going through the main part of today's lesson, which is the domain, the range, the end behavior, and the average rate of change. So our domain, as we remember, is our x dot. Let me write this down. Our x dot. And so when we look at this graph, we can see that it's pointed both directions from side to side. So I'm only looking at the axis right here, right? That's my x-axis. And I can see that they're going both directions, all the way from one side to all the way to the other. An exponential function is almost always the same. So the domain is actually all real numbers. And that's because it goes all the way from one side to the other. It doesn't stop. All the x's keep going and going and going. So the x's will be almost always be all real numbers. For our end, little line, usually a line right here is called the asymptote. So I'll write that right here. Asymptote is that little line showing me what is this function going to. It's getting smaller and smaller and smaller, that interval, until basically it's almost a straight line. And so we want to see where is it, what number on the y-axis is it gearing towards. So this asymptote will help me with my end behavior. We can see looking at this that at 2, when my y is, that is my end behavior, right? That's where the line is gearing towards. So when my end behavior will be when y equals 2. But my exponential function will never ever touch that asymptote. So when I'm looking at the range now, I'm looking up and down, right? I'm looking at this axis. So I can see it goes on forever up that way, but it will always be bigger than my end behavior, bigger than my asymptote. So I know that the y has a number bigger than, because all these numbers, all these y's right here, are bigger than 2. So my range would be y is greater than 2. It wouldn't be equal to because it's never actually going to touch the asymptote. So my range is y is greater than 2. Now, I'm going to do one more with you before I do the average. So I'm going to do this one here. And so the first thing I'm going to do is find the domain. I can see that the domain arrows in both directions, and my side to side, my x value is my domain. Then my domain is all real numbers, which usually is what it is, the exponential function, and actually linear. Our end behavior, now our line is different. So I need to figure out where is that asymptote? Where is that line where it's gearing off towards? So I can see it's kind of ending towards here. So I'm going to draw my asymptote right here. Better. And so I'm always looking at the y for the asymptote. So when I see that, it's gearing off right here when y is 0. So where my yellow line is, or my yellow dots, that is when y is 0. So I'm going to put that right here, y equals 0. My end behavior. That's where the line's gearing. Now, my range, I know that's my y values right here. And I can see that they're all above that number, not below. So y is actually going to be greater than 0. Remember, it never touches my asymptote. So now I'm going to go through and show you average rate of change. And so we know that rate of change, right, means slope. So I'm basically finding the slope of those 2 points, that interval right here from 2 to 3. So let me erase this a bit better. And so I'm trying to find the average rate of change. And they're saying it's the x coordinate when x is 2 and when x is 3. Now, where is that on the graph? I need to go my x right here. And what I need to do is find what the y is when my x is 2. So I draw a line up. You don't have to draw a line, but I want to see what's my y value when my x is 20. That function ends up being 4. So I know this point right here, comma 4. Now I'm going to put that right here. So when my x is 2, my y is on this graph. Then when I go to 3, I'm going to draw my line up again. Now I can see that my y is 8. When my x is 3, my y is 8 when I use that function. So I'll write that right here. 3, comma 8. The next thing you're going to do is find the rate of change or the slope. So basically you're finding this line right here, the rate of from this point to that point. How we do that, first thing we do, label. So I label x1, y1, x2, y2. Then I plug it in. So I have y2 minus y1 over x2 minus x1. So I end up getting minus 4 over 3 minus 2. 8 minus 4 is 4. 3 minus 2 is 1. So my average rate of change is 4. That means each time it will be increasing by 4. So basically, we're just finding the slope of those 2 x coordinates, but we need to find the y coordinates as well. Let's go back to the last one now. So now it gives me the rate of change for this one when it's between 2 and 0. And so right here, I would find, okay, where is x negative 2 up? Now I can go up on the graph. And I can see it touches at around 9. So when my x is negative 2, my y is 9. When my x is 0, let's figure out what my y is. If I go right up here, your y is 3. And then you're just finding the slope. You can always do the rise over run. But right away, you can see this equation right here is decreasing because it's going from here to there, right? It's decreasing. And so because it's decreasing, my slope should be negative. Let's just make sure we do. So I'm going to label y1, x2, y2, and plug it in. 3 minus 9 over 0 minus 2. And when I get that, I get negative 6, and this turns to a plus sign, plus 2, which equals negative 3. So my slope, or my average rate of change between intervals of negative 0 would be negative 3. So now you guys should be trying these on your own. Maybe pause this video, try it on your own, and I'm going to put the answers up when you're finished. So pause it, see if you could try it on your own before you play the video, and then you guys can make sure your answers are right. Okay, so I'm going to replace it. going in. My end behavior, if I were to do this asymptote right here, that's -2, the y equals -2. My range is greater than -2. All my y's on this line are greater than -2. And find the average rate of change from 2 to 3. So let's erase it better. So when 2, 2, and 3. So when my x is 2 right here, my y is 0. So I just comma 0. My x is 3, I'm going to say it's right there. It's at 3, comma 2. I know it's not that exact because the boxes are missing, but hopefully that's correct. So I get 2, comma 0, 3, comma 2. I could just count the rise over run, like up. I'm going up 2 over 1, so I know my slope will be 2. Or I can label, plug it in. This one, I know the domain is always all real numbers. And behaviors were my asymptote. If I look right here, it's carrying off towards where y equals 0. I know that this y's are greater than 0, so y's got to be greater than 0. And now when I find these 2 points, I can see when x is 0, when x is 0, my y is 1. So I would do 0, comma 1 at that point. And when x is 2, my y is 4. And I find the slope. I could also count rise over. So if I'm going to change your y, I'll do it this way this time. Go to the change in x. So the change in y, up and down, right? So 1, 2, 3. So my change in y is +3. My change in x is +2. And you end up getting 3 over 2 or 1.5 as your average rate. We know it's positive because we can see our function going up. +2. Right here, our domain is all real numbers. Answer point. Your range. Well, first I'm going to find my end behavior, which is my asymptote. That's for y equals 7. I know here that my y values are actually less than 7. I can see here my y is 3, my y value is 0. Y's got to be less than 7. And then when I find my average rate of change when x is 0, 0, comma 5. And when my x is 1, it's 1, comma 1. So right there, I find my slope, and I know it's going to be negative. Find the slope at the 5. And so when I do that, I'm going to label, plug in my slope formula, and I get 1 minus 5 over 1 minus 0, which ends up being -4 over 1. And I can reduce that to -4. And that's right because it's a negative going down. Last one. Domain is all real numbers, as always. The end behavior, which I'll do next, right here, that's where it's veering off towards, so it's y equals 2. So that means y's got to be greater than 2. And then when x is 0, let's figure that out. X is 0, my y is 3. When my x is 2, when my y is 10, and I just find the slope of that. So I'll do 10 minus 3 over 0. 10 minus 3 minus 2 minus 0, sorry. 10 minus 3 is 7 over 2, which ends up being about 3.5. And I know it's positive isn't really. All right, so now we're going to word problems. This is the last part before you practice to take your mini quiz. So your IXL was just on domain and range, so that was X3. So after you're done this, you can practice on X3, and that will get your homework. But here's our next problem. So this has to do with real life scenarios, right? I'm in a car, my new car. I'm just time right now. And so when I get a new car, my car depreciates in value, which means my car, when I buy it, it's worth, in this case, $55,000. And so each year it depreciates, which means the value of my car, like if I were to turn in my car, it would be less. It wouldn't be as much money. So I wouldn't, if I were to trade it in, I wouldn't get as much money as I paid for it. So in this case, this person's car depreciates about 10% each year. So we want to find out the value of this new car, and you can do the vintage car on your own after you see my example. I want to find the average of the new car in dollars. I want to find how much it is, the average rate of change between 5 and 10 years. Really, all you're doing, and I'm going to erase after, 50,000, 65,000, and 1 month, but instead of x, we're going to plug in our first time value, which is 5. And we know when we write our points, 5 is going to be the answer. That's what I'm plugging in right here. When you do that, I want you to round to the nearest dollar. You're literally writing this in the calculator. You end up getting 32,477 when you round. That means in 5 years, that car was worth 32,477. Then, to find my 10th year, I'm going to do it again. And do it to the 10th power, which I know my x is 10 to the 10th power. When I do that, and I round to the nearest dollar, and it's 19,170. Which by 10 years in, even though I paid 55,000, now my car's only worth 19,000. Then I need to make sure that I find the slope, because it's average rate of change, right? So the average rate of change, I'm just finding the slope. So same thing we did earlier. Label with label, x1, y1, x2, y2, and plug it in, plug it in. So I have y2 minus y1 over x minus x1. When I do that, I get 19,177 minus 32,477 over 10 minus 5. And I should be getting a negative slope. You can see the car's depreciating. And so if the car's depreciating, my slope should be negative. When you do that, you end up getting negative 6,600, which means when I have the car for 5 to 10 years, each year on average, it'll be decreasing by that much money. So when I explain the meaning for this part, I'm only doing the new car right now because of time. So when I'm explaining the meaning, each year, 5 and 10 years of having and the car, increased by $2,060 each year on average. So this should be a linear function, right? I'm adding and subtracting over and over again, even though we're talking about x. As soon as they say rate of change, you know they're talking about something being added and subtracted over and over again. Now, a lot of you guys on your mini quiz yesterday, when I gave you that equation, you said like he's decreasing by $1.25 or something like that. Remember, something's getting added or subtracted, that's always linear. But if something's getting multiplied, that's exponential. So the next one says average rate of change for the value of a new car between 10 and 20 years. We already got 10 years right here. So 10, 19,177. And so now I need to find 20 years. So to do that, the same thing up here where I do 5,000 in my calculator, y is 1.10 to the 20th power. And when I do that, I end up getting 6,687, which means by the 20th year, my car's only that even that $55,000 car's only worth $6,687. Then of course I need to find the slope again, so x1, y1, y2, and I plug it in. And when I plug it in the slope formula, I end up getting -1,249, which means each year from the 10 to 20 year, it's increased by $1,349. So to explain the difference, you can see in the purple, right? The first the 5 to 10 year mark, so it was increasing a lot more, $2,600, while the last it decreases less value later on. So in the beginning, the first 5 to 10 years, the first 10 years, my car depreciated value. Or then it will from 10 to 20 years after that. That again is because it's the average rate of change. We have an exponential decay, we know something like this, right? So eventually, this slope will be a lot steeper than the slope right here. So that's why eventually it will kind of go to a certain price and then it won't move from there. So I want you to try this one. So pause this. See if you could try to create it. When you're done, unpause this video and I'm just going to write the answers and explain how I did it. So pause the video. All right. So this is how you get the answers. So first, I write the equation. So I have y equals, and I know I started with 285, so I know that my n. That's how many cell phones I started with. Then, I know I'm increasing. So if I'm increasing, I know I'm doing 1 plus. And 75%, I need to put as a decimal. So to do that, here's the percent. I move over to the left. So that ends up being 0.75. So I'm going to 0.75 here. I want to rewrite it to look pretty. Y equals 285. Then you add a 1.75. Then it wants the average rate of change from 2 to 6 years. So I know that x is always 9. I know, again, I'm plugging in 2 for x and 6 for x. So go ahead and do that, and I know those are going to be x coordinates. So I'm literally typing in my calculator right now, just like you guys. 85 parentheses 1.75 and parentheses that caret above the division sign, and I'm going to do 2. When I do that, I get 872.8125, but I'm going to round to $8, so 873. And if I do it again, I do it power, I end up getting 8,186 when I round. And so those are my 2 points. Now I want to figure out what's the average rate of change of people having cell phones towns from 2 to 3 years. So again, I label, and I plug it in the slope formula. So 818 minus 873 over 6 minus 2. And when I do that, I end up getting 0.7313 over 4. When I divide by 4, I end up getting 1.25, which means on average, so if I want to figure out what this means, and I know it should be positive, so if I want to know what this means, I know on average, between year 6, between 2 and 6 years after 1985, number of cell phones by 1,800, and I'm just going to round in, 28 cell phones. So, last one, you can see that they're talking about different dates. So they're talking about 2000, the population was 3,900, and 2006, the population was 6,218. So this is actually a linear equation. That's for the rate of change. So first I have to write them as points. So in 2000, that's right here, 3,900. 2006, there was 6,218 people. And I know if I'm going from this to this right here, from a 3,200, I know my population. When I do that, I find that slope, I label, plug it in, and I'm getting 1,000 divided by 6. Ends up being around 384 when I round. That means the population increases by 380 people a year. But is it possible to tell if it's linear or exponential? No, because we would need a third. You can't tell if it's linear or exponential. All right, at this point, this is the end of the lesson. So what I want you to do, just if you guys want me to practice, you're going to go on X3 and practice to get that IXL done. And lastly, so I know that you watched the video, go and fill out for a mini quiz and hand it in the folder of how you feel about the lesson. There is extra credit question. Extra credit question on this quiz is, what is that word where we see the graph turn off toward? Like there's that line. What's that line called? So our extra credit question, what's that line called? Right here, we have our line veering off towards a certain number, or and there is starts with an A. What is that word called? That's our extra credit question. You can write that either on your quiz or on the back. Now the quiz, let me go over that real quick. The quiz is right here. So what the quiz is, right here, all you're doing is you're finding the average rate of change for this one, right here. You're finding from 0 to 3 on both graphs. So the graph and on the table, you're doing both. And then you're explaining which one has a greater rate of change. You're finding the rate of change between 0 and 3, that interval, for both the table and the graph. Number 2 and 3 is just talking about the graph. You can even start with that if it's a little bit confusing. So it's, what's the domain of this graph? What's the range of this graph? The next one's exactly like the one we did. So it gives you a situation, it gives you the equation. They're saying find the average rate of change for population between 1 and 5 years. So it's basically what we just did. And then interpret the meaning of the average rate of change. Make sure you guys hand this into the folder when you're finished, and I will make sure to grade them Also, make sure you hand in your budgeting packet and your progress report in that period 1 drawer if you, or period 1 and 2 drawer if you have it.